Hello everyone. Today is April 7th. It's a Tuesday, and this is the Utah Water Supply Briefing. My name is Brian McInerney, and I'm the hydrologist with the National Weather Service located in Salt Lake City. This is a long, more technical version of our water supply briefing, and we'll get started here. So when you look at the weather patterns in the precip anomaly, the dominant weather feature is this guy right here. And we've talked about this before, but one thing I wanted to show you is that this big high pressure ridge that has been blocking all of our storms and pushing everything north. This was January of 2015. When I saw this, I thought, I wonder what it looked like last year during January. So I went back in time and looked, and here's what I got. And it's almost an exact replica of what we had in 2014 and 2015. Now I'm thinking we had something similar in 2013 and 2012. But suffice to say, it's this big blocking high pressure that has caused our drought, and we need this to move. We need something to change to kind of break out of this system next year in 2016. When you look at the water year in total, and we'll do this from the start of the water year up until April, what we see are dark colors or warm colors indicate below average precipitation for the month. And when you look at Utah, we have a lot of red, which indicates we only got maybe 11 to 20%. Some areas only less than 10%, and some areas nothing. California is the worst during this time. November, more of the same warm colors, somewhere in the range of 50 to 70% of normal. And this is at the point where you need to start building your snowpack, and we're not doing it. Then December came, and we did have a break through that ridge, and it worked out quite well. And we had precipitation levels that were right around 150% of normal, some areas a little more. But it was right around Christmas time that we did have this storm. And then we moved to January, and things shut off again. The ridge packed back in, and that's what we just looked at, that rendition of the winds at 11,500. But you see maybe southeastern Utah did a little bit better, but really overall not so much. And then February came, and it was very, very dry. Some areas didn't get any precipitation whatsoever in the state of Utah. When you can see Colorado did much better as those storms dropped down from the north and into Colorado. And then you move into March. Northern Utah had somewhere around 20 to 30% precipitation, where southern Utah did better than this time. They had about 5 inches of water in the mountains, and we thought maybe this was going to help them, but it stayed dry, it stayed warm, and it really didn't help them much at all. And then when you look at April 1st through April 4th, we haven't received any precip during this time. So let's take a look at the temperatures that have really plagued us this time. And we've shown this before, but I'll run through it again. When we started it in December, the first 13 days were the warmest we've ever seen. And then we had that 48-day spread where it was above average the entire time. And then we had the warmest February on record, and this is all at the Salt Lake City airport. And now we move to March, and we are at the hottest March on record, and this goes back to 1874. That doesn't mean in 1874 it was as warm. It means that's when we started taking records. Who knows before that when it's been this warm. When you look at this, we've shifted 1 month ahead. It's another way to look at the data. So when you look at the normal February average temperature of 34.2 degrees at the Salt Lake City airport, what happened in January was we actually exceeded the average temperature in January. And then when you look at the normal March, which is 43.6, that happened in February. A little bit warmer. Normal high temperatures for April 7th and 8th is 59 degrees, and we did that in March. So we're 1 month ahead climatologically here in Utah when it comes to temperature. And the question is, what if snow melts early? So this was just a quick study we did looking at the Weber Basin from 2000 to 2005. 2000 to 2004 were very dry years. And when you looked at the normal reservoir inflow, the percent of normal, you can see in 2000 it was 42%, 2001 it was 36%, 2002 34%, and so on. But when you look at 2005, it was 100% normal inflow. And the question is, what was the snowpack on April 1st? So when you looked at the snowpack in 2000, it was 86% of normal. So you would think you would get 86% or somewhere close to that into the reservoirs, and that wasn't the case. When you look at the ratio of snowpack versus runoff, it was less than half during 2000, 63% in 2001. 2002 was the lowest at 43%. But when you look at 2005, the highest ratio was 98%. We had 102% of normal snowpack, and we had 100% runoff. So you're wondering what's going on there. And when you look at the two, we had premature melting in 2002. And when we talk about premature melting, we talk about March. And this year, we have been melting in January. We have diurnal fluxes going on in January, meaning the snowpack is yielding runoff in the month of January at some of the higher elevations. And we looked at north-facing the aspects of the Uinta Mountains. And that indicates that the snow is ripe, that it's about 40% density, and it's producing meltwater. And it's in January, and it's unheard of. It also indicates we've seen a little snapshot of what we can expect in the future with the warmer climate as we progress with climate change. And this is very unsettling at this time. So let's go right into the water supply conditions, and we'll start with the Bear, and we'll look at 2 points. And understand we're at record territory in a lot of these forecasts. So when you look at this graphic, the y-axis is the volume in thousands of acre feet. Time is on the x-axis. The straight, not the dash line, but the solid line is the average. The dash line is the median. And then on the bottom, it's the minimum that's ever been observed. The top little dash line is the max that's ever been observed. And then you see those blue areas of forecasts. And these are the forecasts made by the Colorado Basin River Forecast Center that's part of the National Weather Service. The middle dot is 50th percentile. When you go up the line in that little like kind of a box and whisker kind of thing, you see the range of possibilities. That's the 10th percentile, meaning if it got very cold and wet, that's what we would see. And then if you follow the red line down to the bottom, if it got warm and dry, that's what we would expect. And that's the forecast made in January. There's another one made in February, another one made in March. And then April is the current forecast. And you can see how these lines really throughout the rest of this presentation for the most part have been declining. This is Bear Woodruff Narrows Reservoir, 50% of average forecasted for this year. And then when you look at Logan, that's what we see, and it's 58% of average. Now when you move down into the Weber, a little bit farther south, the conditions deteriorate as we move. So we're looking at the first point is Oakley at 53% of average. Again, the forecast is declining down. East Canyon Reservoir inflow is expected to be 29% of average. And this is the amount of water we forecast from April 1st through the end of July. Only 29% are we expected going in East Canyon Reservoir. Then inflow into Pineview is only at 19% of average, and we're near record territory that went back to 1992. Moving south once again to the Six Creeks area, and we'll look at Little Cottonwood to start with, and it's 53% of average. And it's going down close to the min at 1961. Also in 1961, we broke all sorts of heat records in Salt Lake City. When we move a little bit farther north to City Creek, we see 32% of average, again, closer to the record of 1961. And when you look at the whole Six Creeks Basin, we're only expected to see 20% coming out of the mountains this spring from the Six Creeks area, which is just east of Salt Lake County, our most populated area. Provenir Woodland at 62% of average. Headwater areas, the headwater areas did better. The higher you went, the better it was because we had rain and some of our early storms in December at the lower elevations. The upper elevations got snow where that water stayed in storage in the mountains. But if it rained, we didn't see it now. When you look at Spanish Fork near Castilla, 21% of average, getting close to the minimum we've ever seen at 2002. Now moving over to the Duchesne. We'll look at 3 points there, and we'll start at the Strawberry Reservoir, and that's at 26% of average. Then we'll move over to the Tabiona near Duchesne, which is a headwater area, 54% of average, and then Knight's Diversion, which is kind of an important water supply area, 57% of average. Overall, the Duchesne area is doing quite well with water supply in the reservoirs. They're holding a lot of water compared to the rest of the state. The northern green, upper green, we'll look at inflow into Flaming Gorge at 66% of average. And then we'll look downstream at the green near green at 54% of average. And then we'll move over to Lake Powell, and we'll look at 2 points there. The first one at Cisco, and that's coming from Colorado, and that is right around 68% of average, or 3 million acre feet. And then we'll look at Lake Powell, and that's only expected to be at 52% of average, or 3.7 million acre feet going into Lake Powell. And you can see between February and March, the forecast actually stayed the same, maybe jumped up a little bit due to that late season storm we saw in March, but really the conditions deteriorated. It stayed warm, it stayed dry, a lot of sunshine, premature melt, and the numbers dropped off again. Now when we move over west into the severe, we're going to look at 2 points at Hatch, and we're near record territory near 2002 at only 28% of average, and Hatch has been in bad shape really the whole time. And then we look at Marysvale at 40% of average, near record, and that goes back to 1957. And then moving down into the Virgin, we'll look at the headwater area to start with, Virgin near Virgin, and we see 34% of average, close to the record near 2002. And then when you go down to Littlefield, the outlet, we actually did break the record from going back all the way to 1934 with 16% of average coming out of the Virgin. When you look at it graphically, this is what we see, the average by basin. You can see 20% in the Six Creeks area, 25% down in the Virgin, 35% in the Severe. The farther west you go, the worse the water supply conditions were. The farther east you go, the numbers increased. Still not great, but they increased. And that's due to the storms coming up over the ridge and down into the headwaters in Colorado. But one thing to consider, and this question came up, how are we doing reservoir-wise? And we're doing better this year than we were last year. And you could say, well, how can you do that when you had such a poor year? And it was due to the summertime rains and of last summer. And really, it wasn't the volume of water that we received that really bumped things up. It was the fact that people used the rainwater as opposed to the stored water during this time. And when you look at rainfall during July, we're looking at somewhere around normal to maybe up to 130% in some areas. In Utah, August, we look, and we had all sorts of rainfall. 200 to 300% of our summertime precip, which is really very small when you look at the big picture of water supply. Typically, we don't even take into account thunderstorms during the summer months, but the pull on the stored water was reduced dramatically because for 3 months we had above normal precipitation. And there you see it again. Southwestern Utah had all sorts of flash flooding from heavy thunderstorms. There was 2 decaying hurricanes that moved up Baja, that moved into the area during September, interacted with a low pressure and produced all sorts of precip. Very nice to see, and that helped our water supply situation. So there you have it. There's my phone number. There's my email. Let me know if you would like to see any other data, any other way to package this. This is the last one of the year. We've kind of seen what we're going to get, and it's not very good. I do appreciate the time that you listen to this all the way through, and we'll go and hopefully we'll do better next year. Thank you.